right, it's time, finally. The wait was killing me. Um, Welcome everyone to this talk, a look at the future of software development. All my life, I think I've looked in an optimistic way at the future. And today, for us in the IT industry, we're at an interesting time, I think, to say the least. So I wanted to kind of push into that. I've been doing some stuff over the last year that gives me hope, and I want to hopefully convey some of that. But our future is things are changing, so that's what we're going to take a look at here in this talk. And of course, the star of the talk, of course, is AI. Last year was insane. I've been following AI since I became aware of it, I think around January 23 or something, when things started to pop up. And I'd already been using things like GitHub Copilot for a while, to help me with code and everything. And I'll show you some of that in a bit if you haven't seen that before. But I watch a lot of YouTube videos, all these people talking about AI and everything, and it's like this isn't clickbait. Last week was another insane week, and it was like week after week after week. Last year, there was just these insane things happening at a very rapid pace with AI. So 2023 was insane. But it started at the end of November in 22, when OpenAI kind of let the genie out of the bottle. Because people have been working on AI for a long time. And actually, I've been in software development for a very long time. I'm not going to tell you how long, because I'll look too old. But anyways, I remember attending an AI conference. I think it was back in the 90s. And there was a hype cycle back then. Everybody was really excited about where AI was going, and then nothing happened, and they called it the AI winter. But I don't think we're heading for an AI winter right now. There's going to be some bumps and things, but this one's different. And it started when OpenAI released ChatGPT to the world, and things have just gone crazy. So we're just getting started. And we're kind of at this inflection point where we know things are changing. And all the art I use, I use different AI generators for all these little pictures. And I was particularly happy with this picture because this is kind of the way I feel, and I think a lot of us feel, is like you're almost like a sandcastle and the window's blowing away parts of you right now at a pretty rapid pace. So you can see all this debris floating away from this human figure standing there. And that's kind of the way maybe many of us feel right now. And what's really interesting is that we're at an inflection point, and we're standing at the edge of significant change right now. We're right at that inflection point right now, I think. We're at this end of an era. And for us in IT, there's this kind of weird feeling. And I've had this like all last year. I speak at conferences all over the place. And I felt like, how much longer are the things that we're all interested in right now, and the things that we're talking about right now, like this conference, the last couple of days? How much longer will these things be important to us? What's going to change? What things are we doing now that will be completely obsolete within maybe a very short period of time? Things that we've been doing for decades. I think this is how profound this inflection point is looking to be. And there's a name for this feeling of melancholy and fear, and hopefully some optimism about what the future might bring. There's this one guy I follow on YouTube. His name is David Shapiro. These QR codes are to a couple of his YouTube talks, and I have a QR code at the end of the deck that for all the slides. So if you want to get this, and of course the slides will be available, but at the very end, you can just grab that QR code and you can get the whole slide deck. But he came up with a name for this feeling that we have right now, and it's kind of pulling together a couple Latin words. But anyways, he gave it a name called vesperance. And when I saw this video, I was like, yes, that's the way I'm feeling. Like I said, I'm going to these conferences, like, how much longer is this going to go on before things really, really profoundly change on us? But, I'm an optimist, as I said. So it's not all about the machines. And there's a lot of pessimists out there. I think optimists are kind of in the minority for pessimists. I married a pessimist, a realist. But anyways, I don't think it's all about the machines. I think it's the way we adapt to how we coexist with the machines, how we can prosper, how we can take advantage of these machines, and all the things that are happening. So in the talk, I'm going to go into 3 parts. And bear with me, I did a talk on Wednesday. I'm going to cover some of the material I covered in that talk, but if you were in that talk, what I'm going to be covering here is completely different. It's coming at what I talked about on Wednesday from a completely different perspective and in a completely different context. And I didn't talk about this in that talk on Wednesday, but I call it micromind services. So I'm going to explain what micromind services are. And then part 2, this future is now. We're going to take a brief look at AI coding assistants. And one thing I've been doing at different conferences, I've been asking people, like, how many people here, raise their hands, have been using AI for stuff, for work and so on. How many people are using it for code? That's a lot. Okay, it's gone up a lot. Last year when I was asking, very few hands went up. But during the year, it was changing. So I saw, like, I was at a conference in Denver late last year, and it looked like about 25%. Here, it looked like maybe about 30, almost 40% of the hands went up for people that say they're using it for coding. So things are changing. So probably what I'm going to show you for you guys who have been using it is no news, but it's still pretty interesting. And I'm going to go out on a limb in part 3 in an area that I've been calling test-driven prompt programming. Now, I'm a software developer. I'm not an AI, things like that. I've been writing back-end systems, Java, Python, JavaScript, that kind of stuff for a very long time. But I'm been in the business for a long time as well. So I've been heads down software developer, never managed anything like that. I like having my hands on the keyboard, but I also like to be bleeding edge, always trying new things, that type of stuff. That's why we're all here at conferences like this. So the third part will be really kind of going out there. Some people say it's a bridge too far. I don't care. I like to go to a bridge too far. So this micromind idea, it's not about AI or ML, but it's about building systems, a way of building systems that have this kind of instinctive innate behavior. So if you look at like biological neural networks, and I couldn't really find the ratio of say how much of the real estate in a biological neural network is wired for like instinctive behavior versus how much is there for learning, adaptive behavior, things like that. But we come into the world and other biological neural networks all the way down to insects and worms come in with more and more of the neurons in their neural networks are there for instinctive behavior. So this is kind of what I'm talking about. What I'm going to be talking about with these microminds is not AI or ML, but an approach for doing software that has kind of a more innate or instinctive behavior. And bear with me, because this is what I talked about on Wednesday, but it's based on event-driven, but I'm going to put it in the context of kind of AI, neural networks. But I call this pure event-driven, and we'll get into that as well. So here's a design diagram of an application. The diagonal boxes represents very small, very focused services, and all the wiring is real paths of cause and effect that are going through this system. But there's 13 of these little services. And what this application does is it started out as an e-commerce application, but part of the functionality of this thing is that as orders come in, stock is being allocated to orders. And as stock is getting consumed, that triggers the behavior of requesting more stock. And when stock comes into the system, the stock goes, first it's a hunter, then it's prey. Because what I mean that is when stock comes into the system initially, it hunts for orders that are in a back order state so that those orders in a back order state can be given stock. And when it runs out of anybody that's, any orders are in a back order state, then that stock goes into a prey state. Okay, I'm ready to be consumed by new orders coming in. What blew me away when I was working on this, and I got this working, was the simplicity of the design, but the power of the behavior. I was able to introduce behavioral patterns as I was going through it. It's like, holy crap, I could do this. And each of these little components are relatively simple, very small, very focused components. And that just really kind of blew me away. And it was this behavior that started to emerge from the design that I'd never really seen before in all the years that I've been doing software development. So the way this works is that these services have an API. Commands commit to these services. The commands are requests to perform some kind of a state-changing operation, like add an item to a shopping cart. It's as simple as that. Based on the command and based on the current state of the thing that gets the command, that thing decides, should I emit any events? So the result is it may emit 0 events, it may emit 1 event, it may emit multiple events. This is the basic functionality of the system. And this animation is just showing the cascading flow as this thing is processed. This is a real flow. I use this as a reference as I'm working on the code. As I'm implementing the code, I'm using this as as my design guide. This is a reference to it. Now, here's where things get crazy. The software components, there's only 3 software components that I was using here. There's the diagonal boxes that I called small focus services, and they're called entities. Big surprise. And then there's a view down at the bottom, and the views are CQRS, command query responsibility segregation, but that doesn't really matter in this talk. But the other more important one is the action up above, and that's these actions are in the middle of the wire. And the actions, I'll explain what they do in a little bit, but here's the analogy that kind of started to blow my mind, is that these little services had kind of, not exactly, but it had the fundamental behavior of neurons. And I've been really curious about neural networks and neurons, and there's a lot of, the internet's great when you want to learn things instead of just, going through infinite scroll walls on whatever. But there's all kinds of really great sources out there on biological neural networks, artificial neural networks. But I was really curious about how biological neurons work. And mechanically, they're very simple. The signals come in to a neuron. The neuron has an electrical state. When the state hits a certain threshold, that triggers that neuron to emit a signal. This is pretty much how these little services work. Very simple, very focused. They reach a threshold and they emit events. Commands come in and those are signals in. Events come out, those are signals out. And this is the fundamental change in programming. So another way to think about this is that for the 70 years or so, maybe more, that we've been writing software, we've been writing software in a certain way that's been, for the most part, dictated by the hardware that we run on. So memory, CPU, storage, all those kinds of things that have had a significant effect on the way we write software. Now, there's a new type of software that's kicking our butts, right? It's the AI, neural network type of software. It's a fundamentally different way of writing software that solves problems in a fundamentally different way of doing things, right? So there's these 2 completely separate ways of developing software. I feel like this approach is more like this, inspired by these biological neural networks that inspired the artificial neural networks. So this is the behavior of this system. Non-transactional, simple. It uses, of course it does persistence, but it kind of boils everything down to some really simple ways of doing things. So this is just a very quick introduction to this approach. So the point I'm trying to make is that there's different ways of looking at software, and we're not excluded. If you're not an AI scientist or pure heads full in on the AI way of doing things, the optimist in me says that there are paths forward for us in new different ways of looking at how we develop software, like what I just showed you briefly, that give us the power to do things in much more efficient, much more powerful ways with more powerful behavioral characteristics without killing ourselves in complexity to do it, following the guide of what these fantastic neural networks have shown us. So I want to show you a video of this demo application in action. And again, I showed this at the talk I did before, but I'm going to do it from a different perspective. What's happening here is the dots represent instances of the different services, and you'll see regions emerge here. So this is from a log file with the application running, and I took the log file and I projected it into this video to show the real activity in the service. So all these lines that are appearing are real events being fired from one place that cause commands in another place, right? So this is real activity. The red is back orders. The yellow is orders that haven't been processed yet, and the green is orders that have been allocated stock. So you can see this behavior flowing through. This little micromind has regions, right? Every biological neural network has regions in it. Our brain has lots of different regions. I think it's around 100 or so. And this is the way this system works. And this is why I wanted to do this video, to kind of visually show the behavior of this kind of a system. And when I got the video working, I mean, I can't tell you how delighted I was when I got this working. It was a lot of work. I use Blender to do it, if anybody knows Blender. It's a open source 3D tool. It's fantastic. But it was just, wow, okay, this is how that software worked that I wrote. And it's like, this is too cool. This is too cool. So this micromind, like I said, it's a computing pattern that's biologically inspired by neural networks in a way. It's not heads down like the way that the AI neural networks work. Now, that's a whole different area. But as I said before, the point is that right away, just trying this, these interesting, more powerful behaviors started to emerge. And then, it's like, oh, if I add this one little service over here, I can do this. And it's like, oh, it can't be that easy. It was these kinds of things that were popping up. And just to hammer it home, because I think the neural networks are extremely elegant. And in that, I said this before, but I just want to bring it up again. Neurons mechanically, and I think are very simple. When I talk to people, a lot of times we'll say, well, there's all this other complexity. You say, yeah, you're right, but you're missing the fundamental. The fundamental way that this works is that it's really simple. You have a neuron, signals come in, some signals increase the charge in a neuron, some signals inhibit the charge in a neuron. There's competition that goes on. I just read a book, really interesting, where there's massive competition between neurons. One neuron fires and wants to inhibit all of its neighbors because it wants to win. This is the kind of behavior that's going on. But each neuron mechanically is just as simple as it's getting all these signals, and it doesn't know or care who sent the signals. It's just reacting to those signals. And at some point, it will emit a signal. Now, it doesn't know or care who consumes those as signals, but that's how it works. So that's the fundamental mechanism that's, our neural networks have been kicking butt on this planet for a very long time. We've risen to the top, in the hierarchy of sentient beings on the world. Now, AI neural networks are kicking butt. So this approach, one way to think of it is that this approach has been developed over millions of years of iterative development, trial and error, over and over and over again. And the result, I think, is this really elegant simplicity, but it has profound cognitive complexity and stunningly powerful capabilities, as we're seeing, with our brains, with the artificial brains that are being created. So getting back to reality a little bit here, back to the software level, it's fairly simple. Like I said, a command comes in to one of these things. A command is a request to perform an operation that hasn't happened yet. It's like, please do this for me. Like, please check out this order. The command comes in, and based on the current state and the command, the entity will decide, okay, am I going to change my state? And if so, what events are going to emit? That type of thing. So a one of these things emits, say, an event, like, okay, I'm checked out. So that checkout goes into this, what is called an action, but kind of mechanically is like a synapse, and that event gets transformed into a command, create an order. So checked out the shopping cart event is transformed into a create order command. So that command goes into the order to create an order. The order emits an event that gets transformed into a create a shipping order, that type of thing. This is basically it. Really simple, really straightforward, very patternistic, and it seems to be very powerful. Now, inside of these little entities is just a unit of state. Like I just grabbed the JSON from the shopping cart. You know, it's a shopping cart. It has a list of items in it, but that's it. So, like I said, they're very small, very focused. So, how does this fit into this new age that we're entering? This new age of AI. Well, the fundamental approach I'm talking about here is modeled after these simple networks of neurons. That's where I think the power is at. And the point I'm trying to make here, the main takeaway from this talk is that power of doing something like this is not just reserved to the esteemed people doing AI. I think it's available to us as well. And I'm hoping to see this kind of approach grow, you know, as quickly as time goes on. But these simple components, you know, AI is funny. It's like talking to a toddler sometimes. You know, you ask the toddler to do something and they do it for you. Then you ask the toddler to do something again and they go off in a completely different direction. And sometimes that's the way AI works. So the simpler the task that you give an AI, the more likely it's going to do what you ask it to do. And that's kind of what this is a result of, that this approach for doing software boils down into simple things, which are relatively easy to get the AI assistants to help you with that. So I'm finding I'm starting to write code. First, the code itself is relatively simple, but the way I'm writing the code, and I'll show you a little bit more about this in a few minutes, is done in a way that kind of helps the AI understand what code is being written here. These AI assistants love reusable patterns because you don't just necessarily depend on the training of the AI. What we really want, and this is what's happening very rapidly, is that you want the AI to look at your code, right? Like your project, and use that code as a source of inspiration for how that AI can help you write the next chunk of code that you're working on in that project. So I'm finding that these AIs write code in my style, the way I've been writing code, because it's following my pattern of doing things. So there is this kind of pattern, that, for example, here you can see that this is an entity where APIs are defined, and if you're a Spring developer, this might be familiar, put mapping, patch mapping, and so on. But you can see there's like 3 APIs defined here, and they all follow kind of the same pattern, right? A little bit of a pattern there. AIs love this. Just AI, and I'll show, hopefully it'll work in real time. I'll show you how to do it. But at a higher level, I think for a while, I don't know how long, but I think for a while, we're going to be the important ones at the design level. We're going to be the important ones that know what the system as a whole is supposed to do. It's going to be easy if we can decompose a complex system down into these small components. There's where we can get the boost in productivity with the AIs down there. But having that big picture, having that, compiling all of these specific requirements of the system, that's where I think we're going to be really important for a long time. And I think that that hurdle is going to be hard. It's like we've been working on self-driving cars for a long time, but there's that last 5 or 10% of problems that they've been trying to solve with billions and billions of dollars that they haven't been able to solve. I think we might run into this for a while with the AI, and from a software development standpoint, it will be the big picture is ours for a long time. Who knows how long? Maybe a few years, maybe to the end of the decade. Who knows? I have no idea. And the little picture is where the AIs can really help us. We'll see. But there's all these different patterns, and if you want to get more into it, you can look at the recording I did of the talk on Wednesday. But there's just these, like, there was this great talk yesterday on saga patterns. I touched on a little bit, but that talk was totally focused on saga patterns. This is a lot of saga, this choreography is cause and effect. All the flow is multiple saga patterns in here. There's another pattern is one-to-many, like one signal out from one service gets fired off to send signals to many other services. This is a common pattern in this design. Feeding back on itself is another pattern, but a big one is this reduction tree. So of the 13 services in the system, 4 of them use this reduction tree pattern. And this reduction tree, again, I went into more detail in my other talk, but this reduction tree is a tree structure. The leaves of the tree are like fine-grained data that gets reduced into, like, down to the trunk. And the trunk is, so this is like, what's the current level of stock in the system? And it's taking stock consumption events, or say the leaves of the tree, and they get reduced down to the trunk, which is how much stock has been consumed for this product, that type of thing. And there were multiple reasons for doing this, but it was a recurring pattern. It's like once you're told how to do it, you can use it over and over and over again. And in the AI, you show the AI how to do it once, and then they can mirror it over and over and over again. So a big thing that I really like about this is that it gives us some discipline in our system design process. And I think this is something that's been really missing. Like with microservices, for example. Oh, microservices are great. We've been doing, we came out and it's like, yeah, do microservices. What is it? Well, it's a microservice. It's like, well, what is it? He's like, well, it's kind of like you write the code the same way you wrote the code in a monolith, but just at a smaller scale. It's like, wait a minute. It's like, there wasn't enough detail. Right? There wasn't like enough rhythm, patterns, things like that in it. And so we all kind of went off and we did our thing. We tried things, we learned things, and some disciplines started to emerge. But I always felt like it was kind of undisciplined. Anyways, I feel like this approach, it does give us kind of some very specific ways of doing things, like these patterns. This is another design that I'm working on, but it's just a variation on a theme. These two, this one demo I call Earthship and another one I call Transactor. And then I just wanted to put, this is one of the more critical parts of both of these systems. In Earthship on the left is where stock is being consumed by orders. And on this Transactor thing, it's more about moving funds, and it's where withdrawals are consuming deposits. But if you look at the wiring and the pattern here, it's very similar. So it was like once I got comfortable writing, say, the pattern for Earthship, and then I started working on the Transactor, when I go, I could use that same pattern again. So I felt like, and what kind of surprised me is I get these things working, and it's like, oh, holy crap, they work. It was like, it wasn't hard to reason. It wasn't hard to find where something wasn't working quite right. And it seemed to be almost too easy to get it to work right. And part of it, I think, is, and this is what we've been saying about microservices, some of the things we've been trying to instill in people with microservices, and a lot of people are starting to do this now, is that one of the guidelines for a microservice is you focus on one thing and do it well, and the smaller the better. Loose coupling is extremely important. All these, just like within the biological neural networks and AI, each synapse, each unit in a neural network, it's getting signals in, but it doesn't care about who sent it the signals. All it cares about is the signals that do come in and what work it should, how it should react to those signals. That's all it's doing. That's loose coupling. And loose coupling is important in design. It's important in implementation, and it's important in production. And part of loose coupling kind of goes hand in hand with it is asynchronous communication. That the communication between all these components is loose. And by loose is tightly coupled is request response. You send a request to something, and the requester is waiting for that response. That's a form of tight coupling. Loose coupling is where you just fire something off and you don't care who consumes it. It simplifies things quite a lot. And then finally, the processing occurs across space and time. And what I mean by this is ideal for distributed systems. that these different components, that are in this design can easily be distributed across a cluster. And if, say, one of these services is down, it doesn't necessarily take down the rest of the system. The rest of the system can keep functioning. And when that service comes back up, it just catches up. It gives you that kind of non-brittle characteristic of the application. So let's move on to part 2, AI coding assistance. And boy, there's a lot of activity here right now. So last week when I was putting together some of these slides, I use VS Code. I primarily do Java, but I went into VS Code and I just looked at some of the extensions. So Codium is one that's pretty popular. Tab 9 is another one. Amazon's got Code Whisperer, and I left it out. I use GitHub Copilot. I should have had that there. I've been quite happy with it. It's been getting better, but there is a lot of competition. There's a lot of options to consider and try. They're relatively inexpensive, $10, $20 a month. But if you think about the productivity gains that you get from that, I don't have any problem expensing that, right? And many organizations are just buying enterprise licenses for it as well. There's a new one that came out recently, though, that I'm going to play with some more. I was just talking to the CTO at my company, and he'd been trying, and he said, well, he's pretty impressed with it. And I looked at it briefly. It's called Cursor, and it's a fork of VS Code, but their claim to fame is it's AI first code editor. So I'm pretty pumped to try this one out. So there's a lot going on here. So I want to show you a couple things with GitHub Copilot. So I just want to, hopefully this will work. I'm going to do it live. So I'm in some code, one of these entities, and I'm kind of working backwards, which is just kind of a style that I found that seems to work well with these AIs. I just hit enter, and I haven't typed a single character except enter a couple of times. And you can see the ghost code here. Hopefully you can see it. But it's suggesting a method. And this is exactly what I want. Okay? And this happens all the time. It's like, get out of my head, man. It's crazy. So I'm going to go up. There's another place, another area where I need to add some code. I'm not going to type anything. Let's see if it does it. Come on, you can do it. Let me start typing a little bit. There it goes. That's the method I want. And so my code is kind of written in a pattern. I've kind of fallen into a pattern of this kind of development. So there's another area I want to add some code. Same thing, a little bit more code. It's another one of these event handlers, whatever that thing is. And there we go. Yep, that's what I want. So it's adding code for this back order thing, right? Barely typing anything. And one more, just because the last one that's kind of fun. So let's see, patch mapping, back ordered, yep. That's what I want. Don't want any comments. Boom. That's what I wanted, okay? It doesn't always do this. It'll disappoint you. It'll go nuts on you sometimes. But what I've been finding is that, like I said, I'm starting to write code where I'm experimenting, but I'm trying to write code in a way that helps the AI help me. But it's also, because these are simpler components and they follow simple rules and they have repeatable patterns, the AI can look at other code in this repo and use that as a guide for writing this. The big trick that I found is at the very end of the class is where I've defined all my commands and my events. So a lot of developers, they'll put that into a separate source file, and that makes it harder for the AI to pick this stuff up, right? So I found that putting them in the same source file, makes things better. So here, another thing I want to show you is this. So hopefully you can see it. But I said, it has a chat feature. So I said, using the currently open file as a reference, create a new class named blah, blah, blah. The class contains 2 queries, 1 query for and so on and so forth. And the GitHub Copilot comes back and says, sure, here's a shipping order view class based on the structure, blah, blah, blah. And it gave me this with the 2 query commands. So this is the way CRS views are built using this SDK I'm using here. But the nice thing about this was that it's a lot of tedious boilerplate that's done. You know, these annotations, the class setup and inheritance, you know, extends and all this type of stuff. And it kind of just roughs it out for me, and I'll clean it up and get it to do what I want. This is moving fast, right? It's moving faster with these AI programming assistants. It's pretty wild. All right, so the final part, running out of time here. So this is test-driven prompt programming. So hopefully this will make your heads hurt. I want to do that. I want to make your heads hurt on this. Imagine that the new source code is AI prompts. Right now, I think everybody's thinking, for the most part, that the AIs help us write our code. What I'm proposing here is that the prompts that we write are the new source code. The code that's produced by the prompts is the new assembly language. Okay? Now, just a historical, let's go back in history a little bit. There's this great talk by this guy named Brett Victor, and it was computing. It was something about computing in the future or something. It was this marvelous talk. Anyways, he was talking about when we first started writing code, we wrote code in binary, 0s and 1s, right? And the binary programmers were very proud of their craft. And then came along assembly language. It was like, heretics, well, how dare you, come along with this? You're using computing cycles to take the assembly language and produce the binary code. I can produce the binary code far better than the assembly language. Well, they lost that battle. The binary programmers lost, right? So then we went into assembly language. And then we had the audacity to come up with higher level languages like C and Fortran. And guess what happened? How dare you? I can write much more efficient code in assembly language, but now you're introducing these higher level languages, blah, 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 and then how many people are writing assembly, right? I know a few, but that's few and far between, right? So now what I'm proposing is that we're thinking about AIs. Well, yeah, we'll have the AIs write our code for us, the traditional code that we've been writing for a long time. And what I'm proposing is that think of it this way. Think of it as the prompts are the new source code. And our languages like Java and Python and JavaScript and TypeScript and whatever we don't even look at it. But the key part is the test-driven piece of it. And I'll push into that as we go through this a little bit. But the result is you're producing something it's readable by us, humans, and it's readable by the machines. It's a common language in the form of these AI prompts. And if you think about it, when we're writing software, we're producing unambiguous specifications of the behavior of the system. That's what we're ultimately doing. So the software has the intricate details of the specifications. And so I'm not saying that you can just write arbitrary prompts and expect the AI to just kind of deduce from an ambiguous prompt that it's going to magically produce a system that does what we want it to do. But what I'm saying is that we're doing this in a way that's kind of results-oriented, test-oriented, these prompts in the specifications. And it's iteratively developed doing these things. So just real quick, because I did this last week, because I've been thinking about this concept like for at least the last half of last year. And I've always didn't really dive into the prompts because I don't have a way to take a prompt and actually have it generate code yet, although there's tools that are starting to appear that do these types of things. But I had a conversation with ChatGPT-4, and I kind of explained the concept of this test-driven prompt programming to it. So I kind of warmed it up. Then I said, all right, at the very top, I said, please provide an example test-driven prompt such as the process of a customer adding an item to an order, such as adding an item to a fast food order. And ChatGPT says, okay, here's an example. And it dumped this thing out into, my head exploded because it starts out here, it's multiple pages, but it dumped out prompt, functionality, add an item to an order, user story, blah, 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 input specifications. Where are they? Yeah, input specifications, down there in the middle of the page. What fields are in the request. Expected behavior, listed them out in some detail. And then finally, the test cases. That's the big part that was dumped out, is the test cases. So this kind of blew my mind, because what I realized for the first time was that not only can I write these prompts, but it's the AI and I can write these prompts. So the AI can kind of, again, it's the tedious work. It dumped it all out in a nice template. Now we can go back and fine tune it, tweak it, build it up. So this is the approach that I've been kind of talking about, of using these patterns, simplistic designs, things like that. Letting the AI write the code. So these systems are composed of tightly focused, loosely coupled that do surprisingly powerful things. So I don't know if test-driven is the future or not. Test-driven prompt programming, it's speculation on my part, although other people I think are starting to talk about this. But it's interesting. And again, I'm kind of optimistic about the future and our place in the future in doing it. So we went through part 1, microminds. Part 2, AI coding assistance. We just finished up test-driven. So hopefully I'm going to leave you on a little bit of a high point here, I hope. So in contrast to Vesperance, which is a little bit of a downer, I think, this melancholy feeling about, oh my God, what's happening, to, and I was looking for a word. This isn't a new word like Vesperance, but this word has been used, but I liked it. It's Innovera. And the way I'm defining it is that when you're working with these new tools, I've been experiencing this delight when the AI does something for me that is amazing, like this prompt that I just showed you. That prompt kind of blew me away. It did a bunch of work for me, and it's like, yes, this is exactly what I'm looking for. I can tweak it. I've seen this happen when I generate images. I see this happen when I write code. I see this happen when I write text. I use AI to write text. I'm not ashamed to admit it. It's really powerful, but it's this kind of cool feeling. It's like, yeah, done. Let's move on. Move. Get things done. It's pretty cool. So finally, I just wanted to leave you with this. And I use this in all my presentations. The illiterate 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. And man, I've been using this before it hit the fan last year, but now I think it's even more relevant today, that we have to be willing to let go of the things we cherish now and be willing to embrace the things that are coming at us. So with that, thank you very much. Here's the QR code for the slides. Thank you for so many of you coming. We just have a few minutes for questions, but I'll be around. The other thing I want to mention is that if anybody wants to talk to me, I'm not selling anything. I'm not a consultant or anything like that. But if you just want to chat some more about this kind of stuff, you can reach out to me at LinkedIn or to X or Twitter or whatever, and I'd be happy to set up a chat session with you. So feel free to take advantage of it. And it's a win-win for both of us, I think. So any questions?